Hello students, this is lesson 3.2, Inequalities with Addition and Subtraction. Okay, now I'm sharing my screen with you. Lesson 3.2 in your book is on page 184, although I have not required it on, sorry, my cat jumped up in front of the screen here. She waits till I'm on Zoom. She really likes to be seen, I think. Either way, Um, in this particular lesson, I think it'd be really important for you to look at the book, particularly on pages 184 and 186, as some properties there for you. Okay? So please take a look at these notes. Inequalities with addition and subtraction. The first note I wanted to make for you is this. Solving inequalities is like solving equations. Okay? So basically, to solve an inequality, you use the same steps, which are isolate, opposite, both. Isolate the variable by opposite operation to both sides of the equation. Okay, I'm going to go ahead and just show you this fact. X plus 7 is equal to 2. Okay, isolate the variable, opposite operation to both sides of the inequality. So my solution is x equals -5. Now, if I write the same problem as an inequality, x plus 7, let's just say less than 2. So in a case like this, isolate the variable, opposite operation, and I get x is less than -5. Okay, now you'll notice that in terms of the variable and the answer, the solutions are the same. The solutions to both questions are -5. Simply put, in the equation, -5 is what x is. And the inequality, -5 is what x is not. Okay? And the inequality tells us more than just that it's not -5. It also tells us that the value of x is anything that is less than -5. So for example, it could be -6, -7, -8, -9, and so on. I want to remind you with negative numbers, we're counting backwards. So smaller sounds like it's bigger, okay? Remember, smaller means more, but it means more negative, okay? So -6 is more negative than -4, okay? And the more negative, the smaller it is. Seems a little opposite, but that's how they work. All right, so question is, why does it work? Why is it that when I have an equation, I can get the answer, but an inequality, being something totally different, still gives me the same answer? Now, I wrote a note here that said to see the addition property of inequality on page 184. Just to save time, I'm going to let you look at that yourself, but I put a scale here to just sort of make it easy. Now, when I drew a scale in a previous lesson, you saw that the two sides of the scale were set to equal. Okay? In this particular scale, you can clearly see that they're not equal. This is representing an inequality. So whatever is in the left side of my scale here is heavier than whatever is in the right side. Now, I have a little plus sign here, okay? So if I put a plus sign, meaning that I added something of weight there, but I add the same thing to the other side of the scale, then the scale is going to stay at the exact same level. Why is it going to do that? It's going to do that because in the scale here, I put an equal amount of stuff, an equal weight of stuff into both sides, okay? So therefore, if I put them in equally, then the scale will stay at the same level that it's at before. Okay, just like if my scale was set to equal, like in the previous example from a different lesson, if I put something in both sides of the scale that's the same weight, it's going to stay equal. If I take something out of both sides of the scale that's the same weight, then it's going to stay equal. It's the same thing here is true. If I do it to both sides of the scale, then my inequality will still stay proportionately unequal. Okay? This is what we call an equivalent inequality. Now, I know that that sounds like an oxymoron, like right-left or light-dark. Equivalent inequality. It's just a really strange putting of words. But the word equivalent means that I put the equal amount of stuff into the scale. Inequality means by doing that, it stays unequal at the same amount that it was before. Okay, so that's why it works. Again, and if that's not clear enough, I want students, I'm telling you and informing you, you must go to page 184 to read the addition property of inequality. Okay, I'm not going to necessarily make you memorize the property like we do with some of the other properties, but at least review it and know what it means. Okay, good. I have some problems here for you. X minus 15 is greater than negative 12. Okay, so let's go ahead and solve using IOP, isolate opposite both. Isolate the variable x by opposite operation to both sides of the equation. Oops, sorry, that's supposed to be adding 15, not subtracting 15. Wasn't paying attention to what I was doing. Don't you hate it when you make mistakes and it's on YouTube? All right, so I have negative 15 plus 15 is 0. Negative 12 plus 15 is... Yep, that's right, Evelyn. That is positive 3. Now, let's rewrite everything that we have left over. So I have my inequality symbol greater than, and then I have the letter x. So my solution to the inequality is x is greater than 3. Okay? Now you see we solved it using the same steps as IOP. We're going to do a couple more, and then I'm going to talk about graphing in just a second, okay? So I have n minus 5 is less than negative 3. Same thing. I'm going to add 5 to both sides. Just like in the scale, I added something to both sides, and the scale stayed at the same level of inequality. With the math problem, if I add to both sides, then I'm going to get the same result. So now I have negative 3 plus 5, which would be positive 2. So now I have n minus 0 is less than positive 2. So I'm going to simplify this. I don't need to write the minus 0. And since there's no other negative integer, I don't really need to write the plus sign. So my solution is n is less than 2. Okay? Now again, by adding 5 to both sides, then I change my numbers, but the amount of unequalness stayed the same. Okay? Now, let's take a look at question 3. 10 is greater than or equal to x minus 3. Okay? Now, there's a little hint here. It says to graph your solutions. So, on the first couple of problems here, I did not actually graph them. That was what we did in the last lesson. I just want to encourage you and remind you that each of these should be graphed. The reason I didn't graph all of them is for 1, to save time, and 2, because I didn't leave myself a lot of room to do these sample problems. But I will graph at least 2 of them for you just so that you can see how to do this. All right, so let's go ahead and do this problem. My variable is on the right side of the inequality. Now, I don't necessarily like that, but I'm going to go with it, okay? In standard form, the variable is usually written to the left and the constants are to the right, but I'm going to go with it. So, isolate the variable by opposite operation to both sides of the inequality. So now, my answer is 13 is greater than or equal to x. Now, with a situation like this, you may remember I said in the last lesson that when you graph an inequality, the point of your inequality is going to be in the same direction as the arrow. But if the variable is on the right side, then that will be opposite. So I'm going to go ahead and graph this inequality. So the number in my solution is 13. So I'm going to go ahead and write 13. Since it's positive 13, I'm going to put it on the positive side of the 0. Now I will say this, when you graph an inequality and you have to do 10 problems and make 10 number lines, don't bother numbering 0, 1, 2, 3 all the way to 13. The only numbers that need to be on there are 0 and your solution. If your solution is positive, make sure it's to the right of 0, showing that it's going up. If your solution is negative, make sure it's to the left of 0, showing that it's going down. Okay? So now I'm going to graph this. So let's look at my inequality. Is that an open inequality or a closed inequality? Isai, you're right, it's a closed inequality. So should I have an open dot or a closed dot? Yes, Aaliyah, it is a closed dot. That is correct. So I'm going to go ahead and make a closed dot. Now, you know, my preference, as I had said before, is to put the dot over the inequality symbol. Okay, I'm sorry, over the, what's it called? The graph. Okay, I like it over it just because it's easier to see. So I have a closed inequality and a closed graph. So which direction does the arrow go? Hector, you're right. That is correct. See, now normally the inequality is pointing this way, so I would think I'm going to point it this way. But since my variable is on the right side, then I go the opposite way. Okay. So if I were to read this backwards, then I would say x is less than, I'm reading it backwards, I want to remind you, or equal to 13. So if x is less than 13, then less than would be going to the left. Okay? Just check and see if there's any questions, but obviously you're not really there, or I'm not really here. I don't know. It's a video. Let's move on. Let's do question 4. Isolate the variable, in this case the variable is m, by opposite operation to both sides of the inequality. Now I'm going to rewrite my inequality symbol, and I'm left with m is greater than or equal to positive 9. Okay, now let's go ahead and graph it. I have a, let me move this so that we're not looking at the bottom of the screen here. Okay, so if my solution is 9, the only thing that needs to be on my graph is my solution and 0. Since it's positive 9, it goes on the positive side of the number line. Okay. Open inequality or closed inequality. This is a closed one, so I have a closed dot. Remember, a closed inequality has 2 definitions to it: greater than or equal. Since it has more definitions, then it's more defined, and more defined we're going to call closed for our purposes here. Which direction does the arrow go? This is written in standard form with the variable on the left. So then the inequality point is the same direction as the arrow. And that would be your answer. M is greater than or equal to 9. The value of M would be represented by the dot starting at 9 and going greater than. The closed dot tells me that it could also be 9, or it could also be larger than 9. Okay? Now, one thing I want to point out, sometimes people get a little confused. They're like, I have the variable M, and I have the solution 9. How come I don't write M on here? Okay? And the reason is because the variable is just representing a number. In this case, the number it's representing is 9 or greater. So we don't necessarily have to write the variable here on the graph. Okay, so when you solve, you already know what the variable is in the solution, so we don't need to rewrite it again. So don't put like an M next to your picture here. Just trying to avoid unnecessary mistakes. Okay. All right, let's do some more questions here. Now we have the subtraction property of inequality, which is on page 186. And basically, going back to our graph, the subtraction quality is this. If I subtract the same amount of something from my inequality, then it will stay unequal at the same level. And again, we go to this oxymoron, equivalent inequality. Okay? So if I'm taking the same amount of stuff out, then the scale is not going to even out. It's still going to stay uneven at the exact same level. However, there's less weight in it, but there's less weight equally in both sides of the scale. Okay, back to the problems. So the subtraction property of inequality works like this. I have an addition problem, and I want to use IOB to solve. So isolate the variable by opposite operation. So in this case, my opposite operation is simply subtract. So I'm taking away from my inequality. So positive 6 minus 6 is equal to 0. Negative 4 minus 6, it's a little tricky, is equal to negative 10. Okay, so I have negative 4. I'm taking away 6 positives. Okay, so since I am actually subtracting here, it could look like I'm adding negative 6, but I'm not adding negative 6. I am subtracting positive 6. But if I add at negative 6 or if I subtract a positive 6, either way, I'm still going to end up with negative 10. Okay? So think of it this way. You are 4 feet below the water. You subtract or go down 6 feet. How far down under the water are you? You are 10 feet below the surface of the pool. Okay? Let me say that again. You're already 4 feet under the water. You subtract or go down 6 more feet. You're down, pointing at the negative sign, 10 feet in the end. Just helping you understand integers. They can always be confusing. And one thing I would say with integers, and I can say this from my own personal experience, even if you completely and totally understand integers, if you rush through the problem and don't take your time to really understand it, you can mess up the answer. And I say that because I've done that. I've done that while I was teaching and like gave the opposite answer, because integers do work opposite of just the way that we think. Adding a negative is actually subtracting, things like that. And so you have to do a lot of back and forth in your mind. So it's better to just do it slowly and to ensure that you get the right answer. Okay? Now in this case, the answer is t is greater than negative 10. Let's graph it. Now remember, on your number line, you only need 0 and your solution. In this case, you'll notice that I wrote my solution to the left of 0. Why? Because it's a negative. Okay? So my inequality, is it open or closed? It's an open inequality. So therefore, I have an open dot. Okay, the arrow is facing the right, so my arrow will face the right. Now, let's just make sure that my little clue here didn't like mess everything up. Okay, so let's actually look at the inequality. It says t is greater than -10. So the value of t is represented by the open circle here. The open circle has an arrow pointing to the greater side. Well, I said t is greater than -10, so I put the arrow in the right spot because it's saying that the value of t is greater, or basically starting here and going up. Now I want to remind you, because I have an open dot, that does not include -10, it only includes numbers that are larger than -10. So we could say -9, -8, -7, and so on. Okay? All right, let's do question 6. -1 is greater than or equal to y plus 12. Isolate the variable y, opposite operation. 12 minus 12 is 0. -1 minus 12 is -13. So rewrite everything I have left, and I have -13 is greater than or equal to y. Let's graph it. Now remember, the only thing that we are putting on our graph is 0 and the solution. Okay, so we're at a closed solution, so it's a closed dot. Now, which direction does my arrow go? I'm looking here, and I see that the arrow is going this way, but let's ask the question. So if -13 is greater than or equal to y, then the opposite should be true. Y is less than or equal to -13. Okay, less than. So less than implies that I am pointing my arrow down. Okay. No, that was not the best drawing because I have the 0 there and stuff, but so my arrow is pointing the opposite direction. Well, how does that compare? Oh yeah, this is not written in standard form because my variable is on the right side. Now, if I rewrote it in standard form, I have to flip my inequality to do that. This is the same statement, just stated backwards. Then you can see that my arrow is pointing in the same direction as the arrow here. All right, one more problem. 85 plus v is less than or equal to 120. Okay. Isolate the variable v by opposite operation. Okay, so let's see, 120 minus 85. All right, so I now have v is less than or equal to 35 as my solution here. Okay. By subtracting 85 from both sides. Isolate opposite both. All right, now my solution is 35, so I'm going to put 35 here on the right side of my graph. Remember, I'm not looking at it like, are the intervals 1, 2, 3, 4, all the way up to 35. I'm not concerned with that. I'm just concerned that I have 0 and I have a positive solution, so it's on the positive side of my graph. My inequality, open or closed? Definitely closed. So put a closed dot. Okay, let's see. The equation's written in standard form with the variable on the left, solution on the right, arrows pointing to the left. So that should be my graph. Let's just make sure v is less than or equal to 35. Is this line implying less than 35 or equal to? or equal to because the dot is closed, less than because of the direction of the arrow? Yes, it is. All right, hope you got the lesson. Enjoy.